Hello, in this lecture we will find out the length of chord AB. In the drawing we have semicircle, this semicircle, and inside this semicircle we have three circles. Those two small circles are identical, and the middle circle is tangent to this semicircle at point O, and point O is also the center of this semicircle, and the center of the middle circle is at point C, and we know that AB is parallel to PQ, and PQ equals to 8 units. So PQ, it is actually the diameter of this semicircle, and the diameter of any circle or semicircle equals 2 times the radius. So 8 equals to 2 times the radius of this semicircle. Therefore, the radius PO and OQ will be equal to 4 units. So therefore PO equals to 4 units. That is the radius of the semicircle that equals to 4 units, and OQ, that is the radius of this semicircle, also equals to 4 units. Okay? And the diameter of this middle circle is OX, and OX is also the radius of this semicircle that equals to 4 units, and it is the radius of this semicircle, and it is also the diameter of this middle circle. So the diameter of this middle circle OX equals to 4 units. Therefore, the radius will be equal half of it. That is to say, the radius CX will be equal to 2 units, and the radius OC will be also equal to 2 units. Okay, it equals to 2 units, and we will define the center of this small circle as point M, and actually the distance between the centers of those two circles MC equals to the sum of their radiuses. So if we define the radius of this small circle as R, so the radius of this small circle is R, and the radius of this middle circle equals to 2 units. Therefore, the distance MC between the center of those two circles, MC actually it equals to R, that is the radius of this small circle, plus 2. That is to say, MC equals to R plus 2, because R is the radius of this small circle, and 2 is the radius of this middle circle. So therefore, the distance between the centers of those two circles equals to R plus 2. That is to say, MC equals to R plus 2. And as you can see from the drawing, the diameter PQ is tangent to the small circle at this point. We will define the touching point between tangent PQ and this small circle as point N. We will join together points M and N by a straight line. Mn is the radius of this small circle because it starts from the center of the small circle and ends at point N, that is the point on the small circle itself. Therefore, Mn is the radius of this small circle, that is to say it equals to R. And we actually have point N is the point of tangency of tangent PQ with this small circle, and we have the rule that if the radius, this radius is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency, therefore the tangent PQ will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle also will be equal to 90 degrees. Okay, likewise, as you can see, the tangent PQ is tangent to the middle circle at point O. So OC is the radius of the middle circle, and the radius OC is drawn to the point of tangency, that is to say it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. Therefore the tangent PQ will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So we have here two right angles, and we will draw perpendicular from point M to OC. So, and we will define the touching point between the perpendicular and OC as point D. So this angle equals to 90 degrees, and this angle also equal to 90 degrees. So, and we also know that according to what is given us in the question, AB is perpendicular to PQ. AB is perpendicular to PQ, and we have the rule that states that corresponding angles between parallel lines are equal to each other. That is to say, those two angles are equal to each other, because we have those two, AB is parallel to PQ, and those two corresponding angles are equal to each other, and this angle equals to 90 degrees, so this angle will be also equal to 90 degrees. We will define this point as point E. So I will copy again quadrilateral MC and O in a new page. Okay, so quadrilateral NOCM quadrilateral NO we will define the touching point between those two circles. The middle circle and the small circle is point Y. So actually draw again the quadrilateral NOYD. So in this quadrilateral we have actually we know that here MN is the radius, MN is the radius of the small circle. This is M. MN is the radius of the small circle, that is to say it equals to R, and this is point Y. So MN is the radius of the small circle, that is to say it equals to R, and here in quadrilateral MNDO, in quadrilateral MNDO, we have 3 right angles, 1, 2, 3, and the sum of those 3 right angles is 270 degrees, because 90 times 3 is 270 degrees. So in quadrilateral MNDO, we have 3 right angles that in total they are equal to 270 degrees. 1, 2, 3, the sum of those 3 right angles is equal to 270 degrees, and we will define this angle as angle X. So in total, the sum of those 4 angles, that is to say 270 degrees plus the size of the 4th angle, must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral equals to 360 degrees. I will repeat again. The sum of the angles in quadrilateral MNDO must be equal to 360 degrees. That is to say, the sum of the 3 angles, that is 270 degrees, plus the size of the 4th angle, in total they must be equal to 360 degrees. Here we will subtract from this equality 270 degrees, and we will get that angle X equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle X equals to 90 degrees. So this angle is a right angle. So here quadrilateral MNDO has 4 right angles. Quadrilateral MNDO has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. So I write it down, that any quadrilateral that has 4 right angles any quadrilateral that has four right angles must be at least a rectangle. If not a square, it must be at least a rectangle. Okay, I read again the rule. According to the rule, or rule number 1, according to rule number 1, any quadrilateral that has four right angles must be at least a rectangle. Therefore, we will conclude that quadrilateral MNOD, this quadrilateral, it is at least a rectangle. So I write it down. According to the rule that I stated, quadrilateral MNDO is a rectangle. I will repeat again. Quadrilateral MNDO is a rectangle, and we have rule number 2. According to rule number 2, the opposite sides of a rectangle are equal to each other. I will repeat again on rule number 2. According to rule number 2, the opposite sides of a rectangle are equal to each other. So, in rectangle, this rectangle MNDO, the opposite sides are equal to each other. That is to say, MN equals to DO. MN equals to DO, but we know that MN equals to R, so DO must be also equal to R, because they are equal to each other. So, according to the rule number 2, DO must be also equal to R because of the fact that the opposite sides of rectangle MNDO are equal to each other. So, if MN equals to R, then DO must be also equal to R. Okay? DO equals to R. Okay? And we actually know what is the value of CO. From the drawing, you can see that CO is the radius of this middle circle, and it equals to 2 units. CO equals to 2 units because it is the radius of this middle circle. So we can write here that CO equals to 2 units, and we found out that DO equals to R. So CD equals to CO minus DO. Again, CD equals to CD, this line segment CD equals to CO minus DO. Again, CD equals to CO minus DO. That is to say, CD equals to CO, that is 2 units, minus DO, that is R. That is to say, CD equals to 2 minus R. Okay, CD equals to 2 minus R. Okay, CD equals to 2 minus R. And we have already found out that MC, the distance between the center of those two circles, equals to the sum of their radiuses. That is to say, they are equal to R plus 2. So MC equals to R plus 2. MC equals to R plus 2. Again, MC equals to R plus 2. CD equals to 2 minus R. So we will focus on the right triangle, triangle CDM. In the right triangle, triangle CDM, according to the Pythagoras theorem, in the right triangle, triangle CDM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. I will repeat again. In this right triangle, in the right triangle, triangle CDM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in this right triangle, triangle CDM, is MC. So the square of the hypotenuse is MC squared. Equals to the sum of the squares of the perpendiculars, equals to CD squared plus DM squared. I will repeat again. In the right triangle, triangle DMC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MC square equals to CD square plus DM square. But we have already found out that MC equals to R plus 2. If MC equals to R plus 2, then MC square will be equal to R plus 2 square. And it equals to CD square. CD equals to 2 minus R. So CD square will be equal to 2 minus R square plus DM square. I will repeat again. MC square equals to CD square plus MD square. MC equals to R plus 2, so MC square will be equal to R plus 2 square. And it equals to CD square. CD equals to 2 minus 2. CD square equals to 2 minus R. CD equals to 2 minus R. Therefore, CD square will be equal to 2 minus R square plus md squared. Here we will open the brackets on both sides of equation number 1, and we will get that r plus 2 squared equals to r squared plus 4 plus 4r, and it equals to 2 minus r squared. 2 minus r squared equals to 4 plus r squared minus 4r plus dm squared. So here we have r squared in both sides of equation number 1, so r squared will get cancelled, and we also have 4 on both sides of equation number 1, so 4 will get cancelled. And what is left after we cancelled those expressions? What is left from equation number 1 is that 4r equals to minus 4r plus dm squared. So here we will add minus 4r to equation number 1, this equation. I will repeat again. We will add minus 4r to this equation number 1, and we will get that 4r plus 4r is 8r. 8r equals to dm squared. 8r equals to dm squared. So here we will take a root out of equation number 1, and we will get that the value of dm according to equation number 1, this equation, dm equals to the square root of 8r. Okay, we took a root out of this equation number 1, and we found out that dm equals to the square root of 8r. 8 equals to 4 times 2, so I write it down. md according to equation number 1 of dm is the same. dm equals to, I will substitute 8 by 4 times 2 times r So we actually got the dm equals to 4 times 2 times r. The square root of 4 is 2. So I write it down. So we actually found out that dm, according to equation number 1, dm equals to the square root of 4 is 2 times square root of 2 times r. So in total, we found out that dm, according to equation number 1, dm equals to 2 times square root of 2r. So here we can write down that dm, md or dm is the same, equals to 2 times the square root of 2r. Okay? But we know that MNDO is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO. MD equals to NO, but we know that MD equals to 2 times square root of 2R. Therefore, NO that equals to MD will be also equal to 2 times square root of 2R. So NO equals to 2 times square root of 2R. Okay? So, in the next step, we will join together points M and O by a straight line. Here, we will join together points M and O by a straight line. And we will join together points M and A by a straight line. As you already know, MA is the radius of the small circle. That is to say, it equals to R. MA is the radius of the small circle, therefore it equals to small r. And OA is the radius of the semicircle. OA is the radius of the semicircle, that is to say, it equals to 4 units, because the radius of the semicircle equals to 4 units, and MA equals to R. But what is the value of MO? The value of MO is AO minus AM. I will write that down. The value of OM, it is actually OM equals to OA minus AM. Again, OM equals to OA minus OM. So OM, it is actually equals to OA, that is 4 units, minus OM, that is the radius of the small circle. So in total, we found out that OM equals to 4 minus R. OM equals to 4 minus R. We can write here that OM equals to 4 minus R. So here we will join together points M and O by a straight line. We already found out that MO equals to 4 minus R, and so we will focus on the right triangle, triangle M and O. We will focus on the green right triangle, triangle M and O. I will repeat again. We will focus on the green right triangle, triangle M and O. So, on the green right triangle, triangle M and O, according to the Pythagoras theorem, on the green triangle, triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is MO square. MO square equals to the sum of the squares of the perpendiculars, equals to MN square plus NO square. I will repeat again. In the right triangle, triangle MNO, the green triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is MO, therefore MO square equals to the sum of the squares of the perpendiculars, equals to MN square plus NO square. But what is the value of MO? The value of MO is 4 minus R. 4 minus R. So MO square will be equal to 4 minus R square. 4 minus R square Mn equals to R, so Mn square will be equal to R square plus NO square. NO equals to 2 times square root of 2R. 2 times square root of 2R, so NO square will be equal to 2 times square root of 2R square. So in total, we actually got that according to equation number 2, MO is 4 minus R, so MO square is 4 minus R square. It equals to Mn square. Mn equals to R, so Mn square equals to R square. And O equals to 2 times square root of 2R, so NO square will be equal to 2 times square root of 2R square. So here we will open the brackets on both sides of equation number 2, and we will get that 4 minus R square, it is actually 16 plus R square minus 8R equals to R square plus 2 times square root of 2R square is 8R. So here we got that 16 plus R minus 8R equals to R square plus 8R. So here we have, so actually here it is actually 16 plus R square. 4 minus R square is 16 plus R square minus 8R. 16 plus R square, I'll repeat again. 4 minus R square, it is actually 16 plus R square minus 8R, and it equals to R square plus 8R. Here we have R square in both sides of equation number 2, so R square will get cancelled. And we will add to this equation, equation number 2, 8R. Okay, so what we'll get after we add 8R to this equation, equation number 2, what we will get, it is actually that 16 equals to 8R plus 8R is 16R. So 16 equals to 16R. Here we will divide equation number 2, this equation, by 16, and we will get that the radius of the small circle R equals to 1 unit. So we found out that the radius of the small circle R equals to 1 unit. Okay, the radius of the small circle equals to 1 unit. So we can write here that r equals to 1. R equals to 1, so we know that CD equals to 2 minus r, so, and r equals to 1, so 2 minus r is 2 minus 1, 2 minus 1 is 1, so CD actually equals to 1 unit, r equals to 1 unit also, and in the next step we will focus on those two right triangles, and we will actually prove that those two right triangles similar to each other. So we will focus on the right triangle CDM. We will focus on the right triangle CDM, this right big triangle CDM. And we will also focus on the smaller right triangle CEY. This small right triangle CEY. I will repeat again. We will focus on the right triangle CDM, and on the right triangle CEY. And we will prove that those two right triangles are similar to each other. Okay? First of all, we have those two angles that are equal to each other. They are both right angles. So we can write down that this angle CEY is equal to this angle CDM, and both angles are right angles, that is to say they are equal to 90 degrees. I will repeat again. Angle CEY equals to angle CDM, and they are both equal to 90 degrees, they are right angles. Okay? And we have also this angle C, this angle C, this angle C. It is a common angle. It belongs both to triangle CEY, and it also belongs to triangle CDM. So we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. I will repeat again. Angle C equals to angle C is a common angle that belongs to both triangles. And also we have those two angles that are equal to each other according to third angle theorem. So actually angle CYE, this angle, CYE equals to angle CMD, this angle, and they are equal to each other according to third angle theorem. So those angles are equal to each other according to third angle theorem. I'll repeat again, angle CYE equals to angle CMD according to third angle theorem. Okay, so what is third angle theorem? The third angle theorem states that if you have two angles in one triangle that congruent to two angles in another triangle, then those two triangles are similar to each other according to angle similarity. If you have two angles in one triangle that congruent to two angles in another triangle, then the third pair of angles must also congruent. Again, if you have two angles in one triangle that congruent to two angles in another triangle, then the third pair of angles must also congruent, that is to say, angle CYE equals to angle CMD according to third angle theorem. So we actually proved that all three angles of triangle CMD are congruent to all three angles of triangle CEY. Therefore, we proved that triangle CDM is similar to triangle CEY according to angle similarity rule. So I will write it down. We actually proved that triangle CDM is similar, this is the sign of similar, to triangle CEY according to angle similarity rule. I will repeat again. We actually proved that triangle CDM is similar to triangle CEY according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then you proved that those two triangles are similar to each other according to angle similarity rule. Okay? So from the fact that triangle CDM is similar to triangle CY, we will conclude that the following equality is true. We will conclude that CE over CY in triangle CY equals to CD over CM in triangle CDM. I will repeat again. From the fact that triangle CY is similar to triangle CDM, we will conclude that CE over CY in triangle CY is equal to CD over CM in triangle CDM. Okay? So CE over CY, CE over CY. What is the value of CY? The value of CY as you can see here, the value of Cy equals to 2 units because it is the radius of the middle circle, and the radius of the middle circle equals to 2 units. This is half the size of the radius of the semicircle. Cy equals to 2 units. You can see it from the drawing. Cy equals to 2 units, and all equals to CD. What is the value of CD? As you can see here, the value of CD, it is actually 1 unit. CD equals to 1 unit over Cm. The value of Cm is R plus 2. So in total we got that CE over 2 equals to 1 over R plus 2. But we've already found out that R equals to 1 unit. So in total we will get that CE over 2 equals to 1 over R plus 2. R equals to 1, so R plus 2 is 1 plus 2. 1 plus 2 is 3. So here we'll multiply this equation number 3 by 2, and we will get that the value of CE, it is actually CE equals to 2 over 3 units. CE equals to 2 over 3 units. So here we can write that CE equals to 2 over 3 units. CE equals to 2 over 3 units. So here, as you can see from the drawing, what is the value of ED? The value of ED, it is actually CD minus CE equals to ED. Again, CD minus CE equals to ED. So I write it down. You can see from the drawing that CD minus CE equals to DE. We know that CD, okay, from the drawing you can see that CD minus CE equals to DE. But CD, we've already found out that CD equals to 1 unit. And CE, we've already found out that CE equals to 2/3. So DE, actually we found out that, again, CE equals to 2/3 and CD equals to 1, C equals to 2/3. So in total we got that DE equals to 1 over 2/3. 1 over 2/3 is third, so we found out that DE equals to third. DE equals to third. We will write here that DE equals to third. Here DE equals to third. DE equals to third. So what is the value of OE? From the drawing you can see that the value of OE, it is actually equals to R, that is 1, plus DE, that is third. I'll write it down. The value of OE, this line segment OE, equals to R, that is 1, plus DE that is third. So OE equals to 1 plus third. 1 plus third is 4 over third. OE equals to 4 over third. 4 over third. OE equals to 4 over third units. OE equals to 4 over third, 4 over 3 units. So I will draw again. We will actually join together points B and O by a straight line. We'll join together points B and O by a straight line. And we will focus on triangle OEB, this triangle. Okay, we'll focus on triangle OEB. Actually, here we know that AB is parallel to PQ. So AB is parallel to PQ. I write it down that AB is parallel to PQ. AB is parallel to PQ. From the fact that AB is parallel to PQ, we know that the sum of the angles, the sum of one-sided angles between parallel lines equals to 180 degrees. I will write down that rule number 3 states that the sum of parallel angles, the sum of one-sided angles between parallel lines is equal to 180 degrees. I will read again rule number 3. According to rule number 3, the sum of one-sided, the sum of one, again, the sum of one-sided angles between parallel lines is equal to 180 degrees. So we can implement the rule here. We know that AB is parallel to PQ. Therefore, the sum of those two one-sided angles equal to 180 degrees. Because of the fact that they are located between the parallel lines AB and PQ. Okay? That is to say, this angle that equals to 90 degrees plus this angle that equals to angle BEO plus the size of this angle that is angle BEO must be equal to 180 degrees. Okay? Here, those two angles are located between the parallel lines AB and PQ. AB is parallel to PQ. Therefore, according to rule number 3, the sum of those two angles is equal to 180 degrees. According to rule number 3, the sum of those two angles that are located between the parallel lines AB and PQ, the sum of them is equal to 180 degrees. Okay, here we will subtract 90 degrees from this equality, and we will get that angle BEQ equals to 180 degrees minus angle BEO, angle BEO is equal to 180 degrees minus 90 degrees equals to 90 degrees. That is to say, this angle is a right angle. Angle BEO, angle BEO, this angle BEO equals to 90 degrees. It is a right angle. Therefore, again, angle BEO, this angle is a right angle, that is to say it equals to 90 degrees. Therefore, triangle BEO is a right triangle because it has one angle that equals to 90 degrees. Triangle BEO is a right triangle. So I will copy again the right triangle, triangle BEO. And we also know that OB, that is the hypotenuse of triangle EOB, is equal to 4 units. The hypotenuse OB equals to 4 units because of the fact that the hypotenuse OB is the radius of this semicircle. Therefore, it equals to 4 units. Okay? So, and we also know that OE, we have already found out that the size of OE is 4 over 3 units. Okay, we have already found out that the size of OE is 4 over 3 units, so I will draw again the right triangle, triangle BEO. So the right triangle, triangle BEO, we have two sides that we know the length of them. The hypotenuse is 4 units and side OE is 4 over 3 units. Okay, so here I will draw again the right triangle, triangle PEO. So I draw again the right triangle, triangle BEO. As you can see, the hypotenuse BO equals to 4 units, and we have already found out that the length of side OE is 4 over 3 units. So here we will use the Pythagoras theorem in order to find out the value of EB. Okay, so, and according to the Pythagoras theorem, the value of EB in triangle OEB, in the right triangle, triangle OEB, will be equal to actually OB squared, that is the hypotenuse squared, equals to OE squared plus BE squared. I will repeat again. In the right triangle OEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to OE square plus EB square. But we know that BO equals to 4 units. If BO or OB equals to 4 units, then OB square will be equal to 4 square. 4 square is 16. And it equals to OE square. We have already found out that OE equals to 4 over 3. So OE square is 4 over 3 square plus BE square. So 4 over 3 square is 16 over 9. So I will write it down. We will get that 16 equals to 16 over 9 plus BE square. We will subtract 16 over 9 from this equation, equation number 4, and we will get that 16 minus 16 over 9 equals to BE square. Okay, we got that 16 minus 16 over 9 equals to BE square. Here we will multiply 16 by 9 and then we will divide it by 9 in order to have a common factor with 16 over 9. So we will get 16 times 9 over 9 minus 16 equals to BE square. So we actually multiplied 16 by 9 and then we divided by 9. So we change nothing, and then we will have the common factor with 16 over 9. So here 16 times 9 minus 16 is 16 times 8, so we write it down. Sixteen times 8 over 9 equals to BE square. So here 16 is 8 times 2, so I will substitute 16 by 8 times 2. And we will get that 8 times 8 times 2 over 9 equals to BE square. So here we'll take a root out of equation number 4. We'll take a root out of equation number 4 and we will get that BE equals to the square root of 2 times 8 times 8 over 9. So here the square root of 8 times 8 is 8 and the square root of 9 is 3. So I will write it down. In total we will get that BE equals to 8 over 3 times square root of 2. So we found out that the value of BE is actually 8 over 3 times square root of 2 units. Okay, so in the next step, we will prove that those two right triangles can join to each other. Actually, first of all, AB is a straight line, or anyway, we have here 90 degrees. So we can use the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So here, if we focus on point E, the sum of the angles at one side of point E is equal to 180 degrees, and we have already one angle that equals to 90 degrees, so the second angle must be also equal to 90 degrees in order to complete the sum of the angles at point E, at one side of point E, to 180 degrees. Therefore, this angle OAEO, must be also equal to 90 degrees. Therefore, we have those two triangles, and we will actually prove that those two green right triangles can join to each other. So I will copy again those two green right triangles, and we will prove that those two green right triangles can join to each other. So actually we will have two triangles, triangle OEB, it is the first right angle, so we will actually prove that those two right triangles can go into each other. Or triangle OBE, that is a right triangle, can go into triangle OEA, that is also a right triangle. Okay, so I write it down that we will prove that triangle OEB is congruent to triangle OEA. I will repeat again. We will prove the triangle OEB, the right triangle OEB is congruent to the right triangle OEA. So first of all, we know that OB equals to OA. They are both the radiuses of the semicircle. So OB equals to OA equals to 4 units. They are the radiuses of the semicircle. Therefore, they are both equal to 4 units. I'll repeat again. OB equals to OA equals to 4 units. OB equals to OA equals to 4 units because they are the radiuses of the semicircle. Okay? And we also have the common side OE. OE is the common side. It belongs to both triangles. So we can write down that OE equals to OE is a common side that belongs to both triangles. OE equals to OE is a common side that belongs to both right triangles. OE equals to OE is a common side that belongs to both triangles. So we actually proved the triangle OEB is congruent to triangle OEA. We proved the triangle OEB is congruent to triangle OEA according to if we have the hypotenuse and the perpendicular in two right triangles that are equal to each other, then the two right triangles can go into each other. So if the hypotenuse and the perpendicular in two right triangles congruent, then the two right triangles can go into each other. I will repeat again. Triangle OEB is congruent to triangle OEA according to the rule that if the hypotenuse and the perpendicular in two right triangles congruent, then the two right triangles congruent to each other. Okay? We proved that the hypotenuse and one perpendicular congruent in those two triangles, those two right triangles. Therefore, we proved that those two right triangles can go into each other. And from the fact that those two right triangles can go into each other, we will conclude that side AE equals to side EB, AE equals to EB, AE equals to EB according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? AE equals to EB. But what is the value of AB? You can see that the value of AB, from this drawing you can see that AB equals to AE plus EB. From the drawing you can see that AB equals to AE plus EB. Okay, but we know that AE equals to EB, so we can substitute AE by EB, and we will get that AB equals to EB plus EB, AB equals to EB plus EB. That is to say, AB equals to 2 times EB, and we have already found out that EB equals to 8 over 3, EB equals to 8 over 3 times square root of 2. Okay, again, AB equals to 2 times EB, and we have already found out that EB equals to 8 over 3 times square root of 2 units. So 2 times EB will be equal to 2 times 8 over 3 over square root of 2 units. That is to say, AB equals to 16 over 3 times square root of 2 units, or in terms of numbers it equals to 7.54 units. No, I made a mistake. It is actually equal to, okay, it equals to 7.54 units. Okay, I will repeat again. The size of line segment AB, or the size of chord AB, equals to either 16 over 3 times square root of 2 units, or in terms of numbers, AB, chord AB equals to 7.54 units. Okay, so here the value of AB of chord AB, this chord AB, equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the value of chord AB, this chord AB, equals to 7.54 units. Okay, the value of this chord AB equals to 7.54 units. So now I will summarize the lecture. Actually, we wanted to find out the value of the size of the length of chord AB, and in order to find out the value of chord AB, we have here the semicircle, and we know that the center of the semicircle is at point O, and at point O the middle circle is tangent to the center of the semicircle, and the middle circle is also tangent to this semicircle at point X, and the center of this middle circle is at point C, and we want to find out the length of chord AB. So uh, we I draw again the rectangle. Here we have, if we relate to the quadrilateral MN or this quadrilateral, it has 3 right angles. So the 4 right angle x will be equal to, we know that the sum of the angles in any rectangle is equal to 360 degrees. That is to say, the sum of the 3 angles, that is 270 degrees, plus the size of the fourth angle, that is x, must be equal to 360 degrees. We subtracted 270 degrees from this equality, and we got that the size of angle x is 90 degrees. So this angle is a right angle, it equals to 90 degrees. So here we have quadrilateral MNOD that has 4 right angles. And any quadrilateral that has 4 right angles, it must be at least a rectangle, if not a square. So quadrilateral MNDO is at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other, so we know that MN equals to R. But this MNDO, it is a rectangle, therefore its opposite sides are equal to each other, that is to say MN equals to DO. And if MN equals to R, then DO will be also equal to R. So MN equals to DO equals to R. Then we actually related to, I presented to you the rule number 2 as that opposite sides of a rectangle are equal to each other. So I already mentioned. Then we related to the right triangle CDM, and the right triangle CDM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say MC square equals to CD square plus MD square. MC square equals to CD square plus MD square. But we know that MC equals to R plus 2 and CD equals to R, to 2 minus R. CD equals to 2 minus R, as you can see from the drawing. So MC square is R plus 2 square, and CD equals to 2 minus R, so CD square is 2 minus R square plus MD square. So we open the brackets in equation number 1, and we got that R plus 2 square equals to R square plus 4R, and it equals to, here we open the brackets of 2 minus R square. 2 minus R square equals to 4 plus R square minus 4R plus MD square. So we have here R square in both sides of equation number 1, so R square will get cancelled, and we have also 4 in both sides of equation number 1, so 4 is also cancelled. What is left after we cancelled the expressions? What is left? It is actually 4R equals to minus 4R plus MD square. Here we added 4R to this equation, equation number 1, and 4R plus 4R is 8R. 8R in total, we got that 8R equals to dm square. 8R equals to dm square. We took a root from equation number 1, and we got that dm equals to the square root of 8R. we know that 8 is 4 times 2. We substituted 8 by 4 times 2. And the square root of 4 is 2. So in total we got that dm equals to 2 times square root of 2r. And we know that OM equals to OA minus MO. Okay. Here OM equals to OA, that is the radius of the semicircle, minus AM, that is the radius of the small circle. OM equals to OA minus MA. OA equals to 4, that is the radius of the semicircle, and MO equals to R. So in total we got that MO, side MO equals to 4 minus R. Then we focused on the right triangle M and O. In the right triangle M and O, the green right triangle M and O, the square of the hypotenuse equals to the sum of the squares of the perpendiculars according to the Pythagoras theorem. That is to say, MO square equals to MN square plus NO square. MO square equals to MN square plus NO square. We know that MO equals to 4 minus R. So MO square equals to 4 minus R square. MN equals to R, so MN square equals to R square plus NO square. We found out that NO equals to 2 times square root of 2R, so NO square will be equal to 2 times the square root of 2R square. We open the brackets on this side of the equation, and we got that 4 minus R square equals to 16 plus R square minus 8R. And it equals to R square, and the square of 2 times square root of 2R is 8R. So here we have R square in both sides of equation number 2, so R square will get cancelled. And what is left after we cancelled? Actually here we have we added 8R to this equation number 2, and we got that 16 equals to 8R plus 8R, 16 equals to 16R. We divided equation number 2 by 16, and we got that the radius of the small circle equals to 1 unit. Then we actually proved that the two right triangles, triangle CDM is similar to triangle CEY. And repeat again, triangle CDM, the big right triangle, is similar to the small right triangle, triangle CEY. And we proved that they are similar to each other because of the fact that angle CEY equals to angle CDM equals to 90 degrees. Those two angles are right angles, they are both equal to 90 degrees. Therefore they are equal to each other. Angle C equals to angle C is a common angle that belongs to both triangles. This angle, angle C, belongs to the triangle CEY. Angle C also belongs to the right triangle, triangle CDM. Therefore, we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. And those two angles, they are equal to each other according to third angle theorem. And what is third angle theorem? Third angle theorem states that if two angles in one triangle can go to two angles in another triangle, then the third pair of angles must also can go. So they are equal to each other according to third angle theorem. Actually, we proved that all three sides of triangle CEY can go to all three sides of the right triangle, triangle CDM. Therefore, we proved that triangle CDM is similar to triangle CEY according to angle similarity rule. So, what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle can went to all three angles of another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude that the following equality is true. We will conclude that CE over CY in triangle CUY is equal to CD over CM in triangle CDM. So CE over CY. What is the value of CY? The value of CY, it is actually the radius of the middle circle. As you can see here, CY, this is CY, it equals to 2 units. So CY equals to 2, and it equals to CD. What is the value of CD? As you can see from here, CD equals to 2 minus R, and R equals to 1. So CD equals to 2 minus 1 is 1. So CD equals to 1. Here CD equals to 1. And CM equals to R plus 2. CM equals to R plus 2, and R is 1. So R plus 2 is 1 plus 2, and 1 plus 2 is 3. So CM equals to R plus 2, and R plus 2 is 3. So in total we got that CE over 2 equals to 1 over 3. We multiply the equation number 3 by 2, and we got that the value of CE is 2/3. The value of CE is 2/3. So here you can see from the drawing that CD minus CE equals to ED. Again, CD minus CE equals to ED. Okay? CD minus CE equals to ED or DE. We know that CD equals to 1 unit and CE equals to 2/3. Therefore, DE equals to 1 minus 2/3 is third. DE equals to third. CE equals to 2/3, and CD equals to 1. So what is the value of OE? OE, as you can see from the drawing, OE, the value of OE, it is actually R plus third. R plus third is the value of OE, or R is 1, so it is 1 plus third. The value of OE is 1 plus third, that is to say, it equals to 4 over 3 units. OE equals to 4 units, so we found out the values of all the line segments here. Then we know that AB is parallel to PQ, and according to rule number 3, the sum of the angles of the sum of one-sided angles between parallel lines is equal to 180 degrees. Therefore, 90 degrees plus angle BED, here 90 degrees plus angle BED, 90 degrees, we know that AB is parallel to PQ, so 90 degrees plus angle BED, this angle, 90 degrees plus angle BED, must be equal to 180 degrees because those two angles are located between the parallel lines PQ and AB. Also 90 degrees plus angle BED, this angle must be equal to 180 degrees. So here we subtracted 90 degrees from this equality, and we got that angle BED equals to 90 degrees, that is to say it is a right angle. Angle BED, it is a right angle, therefore triangle BED is a right triangle. Triangle BEO. Triangle BEO. Okay, it is triangle BEO is a right triangle because it has one angle that equals to 90 degrees. triangle BEO is a right triangle. So I draw again triangle BEO that is a right triangle. In this right triangle, triangle BEO, we know that EO equals to 4 over 3 units, and BO, that is the hypotenuse, equals to 4 units because it is actually the radius of the semicircle that equals to 4 units. So here we will calculate the value of BE according to the Pythagoras theorem, and the value of OE according to the Pythagoras theorem will be equal to BO square, or B square equals to OE square plus BE square according to the Pythagoras theorem. OB equals to 4 units, so OB square is 4 square. 4 square equals to 16. OE equals to 4 over 3 units, so OE square will be equal to 4 over 3 square plus BE square. So here 4 over 3 square equals to 16 over 9. So we got that 16 equals to 16 over 9 plus BE square. We subtracted 16 over 9 from this equation, equation number 4, and we got that 16 minus 16 over 9 equals to BE square. So here we multiplied 16 by 9 and we divided by 9 in order to have a common factor with this expression. So in total we got that 16 times 9 minus 16, 16 times 9 16 times 9 minus 16 over 9 equals to BE square. 16 times 9 minus 16 is 16 times 8. So 16 times 8 over 9 equals to BE square. We know that 16 equals to 2 times 10. 16 equals to 2 times 8. So we will get that 8 times 2 over 9 equals to BE square. We took a root out of this equation number 4, and we got that BE equals to the square root of 2 times 8 over 9. The square root of 8 times 8 is 8, and the square root of 9 is 3. So in total we got that BE equals to 8 over 3 times square root of 2 units. Okay? Then here we actually have two right triangles, and we actually proved that those two right triangles can go into each other. Why those two right triangles can go into each other? Because of the fact that they have the same, the hypotenuse AO equals to BO equals to 4 units. The hypotenuse equals in both triangles, so AO equals to BO equals to 4 units. This is the radius of the semicircle that equals to 4 units, and OE is a common side, it belongs to both triangles, so OE equals to OE. Therefore, triangle OEB, the right triangle OEB can go into the right triangle OEA according to the rule that if the hypotenuse and the perpendicular in two right triangles can go in, then the two triangles can go into each other. So we have in those two right triangles the hypotenuse and this perpendicular can go into both triangles, therefore those two triangles can go into each other. Okay, so triangle OEBs can go into triangle OEA, and from the fact that those two triangles can go into each other, we will conclude that AE equals to EB. According to the rule that corresponding angles in congruent triangles are equal to each other. And what is the size of AB? The size of AB, from the drawing you can see that AB equals to AE plus EB. AB equals to AE plus EB. But we know that AE equals to EB, so we can substitute AE in this equality by EB. And we'll get that AB equals to EB plus EB, that is to say AB equals to 2 times EB. So AB equals to 2 times EB, and we've already found out that the value of EB is 8 over 3 times square root of 2 units. and 2 times EB equals to 2 times 8 over 3 times square root of 2 units, that is to say AB equals to 16 over 3 times square root of 2 units, or in terms of numbers, AB, the size of chord AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. I will repeat again. The size of this line segment AB equals to either, or the size of this chord AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the size of chord AB is 7.54 units, or it equals to 16 over 3 times square root of 2 units. Okay, thank you very much.